aim of this practical is to perform different psychrometric processes, heating and humidification. So for humidification we have to add water into the humidifier. So it will in humidifier the heater will create steam from the water, and that steam will flow in the evaporator which humidify the inlet air. So for heating we have to start the air handling unit as well as heater of the evaporator as well as the humidifier heater. Now after some time we can take reading of the dW wet bulb temperature, dBT, WBT and dry bulb temperature with the help of sling psychrometer. This is a sling psychrometer. By using this psychrometer we can measure WBT and dBT of the inlet condition as well as outlet condition. So this is how we can take reading of dBT and WBT for the air inlet. Same procedure for the air outlet. So with the help of this sling psychrometer we will get dBT, WBT for the both condition, inlet and the outlet. By using this flow meter, anemometer, we can calculate the velocity of the air in meter per second. So this is how we will get the velocity of the air by using this flow meter. Let's do the calculation for the heating and the humidification. So here we have two values, inlet conditions dBT and WBT, which is 24 degrees Celsius as well as 18 degrees Celsius. The air velocity is 3 meter per second. Dry bulb temperature and wet bulb temperature at the outlet conditions are 29 degrees Celsius and the 21 degrees Celsius. So by using rho AV we can calculate the flow rate of the air, where rho is the density of the air, A is the area of the duct and V is the velocity of the air. We can calculate the theoretical heat transfer by MA H2 minus H1. For value of H2 and H1 you can use psychrometric chart. By the inlet value dBT and WBT you can locate point number 1 in the psychrometric chart, and from the chart you can get the value of enthalpy, which is H1. Similarly, by using outlet conditions value dBT and WBT you can locate point number 2 in the psychrometric chart and get the value of H2. So by MV H2 minus H1 we will get theoretical heat transfer, which is 1.836 kilowatt. By using MCP delta T we can also get the practical heat transfer, which can be nearly to the theoretical heat transfer. So this is how sensible heating and humidification takes place.